delay of starting the ADB, the previous classes, so it's 5 minutes late. Okay, so let's start. So, however, in case of the severe weather like the snowing, it may be possible based on my experience until in Connecticut, the northeast is up to the end of March or sometimes the beginning of April, there will be snow. So, in case the campus is closed, automatically cancel the class. At that time, depending on the progress of the lecture, so I can provide the online lecture, or sometimes it may be possible to cancel the entire class and catch up in the next class. Or I can have the online class using the tool. What is the name of the online lecture tool on campus? Anyway, using the online lecture tool, so I can offer, or I can provide a recorded video. So please stay tuned in case of the severe weather. But this morning is just the 30-minute delay of my class by myself. But in case of canceled or something delayed, I will send the campus message so you can check whether you guys need to come or not, or the late. Okay. So today we are going to start the main subject of the operating system, that is the process management, as well as the thread the next week. So pretty much the process management will be the major part of that. So before we start on Thursday, we are going to start the first exercise lab for the basic Unix command. But to do that, we need to, each student should have the compute engine. The instances. So the Thursday, please bring your laptop, and hopefully the all student have the coupon code, activate the coupon code. Then, if possible, this semester I do not have any plan to offer the basic GCP lab in addition to this outside of the class lecture. So last semester I did. But this semester, many of the students already use the GCP in the previous classes. So, but if you are new for the GCP, please study by your catch up. It's not very difficult. So you can just follow the step by step on the GCP exercise lab. Okay, after you activate the coupon code. Then what we need in this semester is one operating system, the Unix, the Linux operating system. Either the Debian or the Debian and CentOS. So you can create your virtual machine using the GCP compute engine. So before you come to here, please practice by yourself. But in the Thursday lab, the GA will start from creating the compute engine. Okay. So please bring your laptop. Your laptop should be running at least 30 minutes. Okay, so I think this room has the power outlet. Some of them not enough the power outlet. So please charge fully for your battery. Then we will have the exercise lab. Okay. Any question regarding to the GCP? Just enjoy and create and delete and do something. If there's something wrong, you can just delete. Okay, that's fine. However, if you create a really big and high specification of the virtual machine, you need to disable or delete if you are not using. Otherwise, it will be charged and the coupon will be quickly dried up. Okay. So please, if you are not using, or if you create the cluster, like the 100 node, or something like that, please disable. For the fun or practice is fine. After that, don't forget to delete. It will not be, even though you are using the $300, the free trial for your Gmail, it will not be charged. Even though you put the credit card, they will ask. With your permission, they will use your credit card. So in case you are practicing the $300, the free trial. So to do that, you need to put the credit card information, but it will not be charged. But the AWS, some of the students are interested to use AWS. AWS is automatically charged after your coupon is done. So be careful. So always keep in mind. I think the mostly operating system is okay throughout the semester. But in case you you do not have the enough balance of your the coupon code, and it's called the billing account. So keep in mind that this is a basic thing. So you have the Gmail account. Under the Gmail account, you will create the billing account. So billing account, you can create a number of, like the credit card number 1, credit card number 2, or sometimes you can use the coupon. Under the billing account can have the number of project. When you create a project, at least one of the billing account should be connected. Okay, so which means if you activate the coupon code, so automatically CPSC, the 503 operating system billing account is created. Okay, so when you create a project like the CS, the 503 project, then this one will be connected. However, if you use your credit card only the billing account, it will be charged if that is connected. Okay, this is how it works. But you can see the balance anytime if you go to if you practice the basic GCP lab. There are menu left-hand side. You can always check your balance, and also you can set up your dashboard on the console. Console is the main portal to access any service of the GCP, so you can see the remaining balance or how much you used and what service you are using, or any error, something like that. And also one more thing is you need to invite me and the GA for your project. Then the GA can access the instance virtual machine for grading purpose. Okay. If you have any question during your practice, please contact the GA or me regarding to the GCP, because we are not going to spend a lot of time for only GCP. So I think you are able to catch up using the basic lab. Okay, so today we are going to continue start the process management. Any others? Yes, okay. So what is this? This is our computer that we are going to use throughout the semester for your life, I believe. Unless you change the really different way of the career path. So we will still go, for me, yes, from the 1996, once I joined the IT company, the IT department, so I should live with this one. It's a computer. So it is very important to understand the computer itself. Okay, surprisingly, even the employee in the working in the IT company or the real project, some of the developer or the expert, they don't understand really what is a computer, which means the computer architecture. It is the basic thing for the IT or the computer science to understand the computing architecture itself. More details, a little bit more details. I just touches the taste what is a computer last a few weeks, last 2 weeks. But if you already took the computer architecture class, please review. That is the starting point, baseline. Okay, always. It's not suddenly changed. Computing architecture will not be changed suddenly. Program language may be changed. It's like nowadays, for example, Python replaced many other program languages. Even though we are using the C++ and I think the C++ for the OOP, right? So many of the universities actually use nowadays Python for the CS101, CS102, the advanced data structure, even the OOP. So Python is also object-oriented programming language. So you can do the object-oriented the project using the Python is quickly changed. However, computer architecture is not quickly changed. Once you have it, from the point you want the computing architecture, we have the processor, we have the memory, we have the other I/O device connected by such the bus will not be changed. Which means that we need to understand how to use the memory, the primary storage. That is also very important. The CPU is a processor. If you are in the computer engineering or electrical engineering, it is suggested required to understand the processor part and the assembly language. But for computer science, it's not practically needed in the future and so on. But the memory is to understand why we need object-oriented concept instead of the C language, which is based on the struct. And so idea, the motivation is from the actual memory. So memory is address. It's hard to understand such an address, reference. So because of that, we keep the abstract, such the difficulty of using the memory address by defining object or using class. And even the Java program language is still hard to define the class. And even though we hide the abstract, such a class itself and just create the function, then create the object, and so on. So we have the CPU and the memory, and they are connected to other devices. So this is our computer. This is our thing that deal with the operating system class. So what is operating system? It's a software. Software means it's a program. Just like the MS Word or the PowerPoint, it's the same level, but it's different from such an application program because we need the operating system to use this one. It's the interface between the user and hardware. So eventually we'd like to use the hardware resources. So operating system, when we need the power up, so through the BIOS check and such a firmware level, the processing, eventually the first process, kernel process, will be started. Start means what? Loaded into the memory. So today we are going to see how we can load how can we create the process and how can we use the computing resource using such a process or the job. Okay, so what is the process? The last time that we defined what is a process in operating system. Is that data structure. So as I mentioned, so probably if you took my course, so any of my questions can be answered by the data structure. Everything that we are learning or that you are studying in the computer science department or the computer science major, including computer engineering, is related to the data structure. So why? Computer, this one is different from the human being, Homo sapiens. Okay, you cannot understand what we are thinking. You cannot process as you are understanding the information or the data. So it can be based on for example, the 0 or 1 binary number. However, it can do a lot of things. How? Because of data structure. Okay, so which means it should be formatted, it should be regulated. There is a very clear constraint and the concept and the rules to do something. The process is another thing. Okay, so what is a process? The last time we discussed about the process. Process is the set of instruction. Okay, set of code or set of instruction. Why do we call the code? Because it's not just 0 or 1, the bunch of 0 or 1, they are coded, okay, based on the rules, okay? That is the number of instruction. By the way, who provides such an instruction? Programming is the CPU, okay, hardware also. CPU, like the Intel, the AMD, when they designed their processor is the main thing. As you know, the CPU is like the brain of the body. Okay, it's the main thing, most important part. It is true. Then when such a vendor design such a processor, they decide that this command will be the process handled by this one. Then the other software operating system, everything should follow, should use only that instruction. That is the assembly code. But it's not easy, right, to use. I know that some of students are very good. They can directly code the assembly code, assembly language, but most of them are not. Okay? It's a very low-level language, or sometimes called a machine language. So it's a very difficult, like the 1, 0, 0, 0, or 0, 1, and 0, 0. This is what? Nobody knows. It's a move, for example. Okay? So I'm not sure either. So let me erase. So like this one. So 2 bytes, the 16-bit, represent something instruction code and the register information. What is so like instead we like to move the R1, R2, to move the address, the data in this address, move to this one. Okay, even this is not easy. So what we are using is the high-level language. Okay, like the C. So for example, we are going to start to understand the process. We are going to start from this one. Where is it? Oh yes. So instead, even this one, number of instructions are not easy. You don't have to worry about the meaning of this one. This is just the instruction code of this. Everybody can understand this. This is from the 10 and print. The I is 10. Very simple, even not the loop. Okay? So just to display the number 10. Okay? Then but inside it will be very complicated. So this is the instruction code, the number of code. Okay, so we are going to start from here. However, so we need to translate into the machine language because the CPU can understand only this one, because when the people design the CPU, that CPU can understand this only. So we need to follow that rule, but we don't know. So we need the compiler. So in this case, we are going to use. That is the reason. Even though you compile the exactly same the operating system, same source code, but for example, I'm using i5, but you are using AMD. Everything are the same, but except the CPU, you need to compile again because each CPU uses a different instruction. Okay. What about Java? Compile once, run everywhere. Why? It's a virtual machine. On top of it, even though they are different, there are virtual machine. The JRLib, runtime environment, is the program to create the virtual machine that hide the abstract, the hardware level. So you don't have to worry about the on top of that is running. So which means such a compiled code, bytecode, so that class file. So class file can be processed by the inside the virtual machine. So that is the reason you don't have to compile again, just use such a class file again and again. However, otherwise we need to compile every time. If you are using different CPU, then finally we will get this one. So this is called the instruction code. So we have such a program like the A.out file. So somebody said even A.out executable file is the process, but it is passive process. There's nothing you can do without help of other. This is just the number of instruction. Okay, set of instruction as you have seen here. There's nothing you can do without help of other resources. Okay, so some of them call the program executable file as another type data structure of the process, but it's a passive process. Okay, so using this one, there's nothing you can do. Instead, to use the computer resource for this, the instruction code, we need to. Unfortunately, the CPU cannot read the instruction directly from your hard disk drive. Why?
It's not loaded into memory.
Why? So instruction code.
It's not in binary.
It's just slow. First reason, it's very slow. Okay, the secondary storage or USB or external disk or hard disk drive, it's very slow comparing to the CPU speed. Okay, you cannot get the full benefit of the CPU processor. Okay, so instead we need to faster meter. That is the memory. That is the reason it's called the primary storage. So, which means we need to copy, load into the memory. Okay, that's what we discussed the class. Then, which means this is the memory. Many of the time, probably the instructor used this kind of rectangular lower address and higher address. Why? Because memory is nothing but set of address. It's a sequence of address. Everything is address for the memory. That is the reason. Details inside, we have the different approach to store the binary data, like the little endian, the big endian, and so on. But in this class, we just use such a simple lower address and the upper address. That actually enhance the memory part. Then, the lower address part mostly used by the operating system kernel. Okay, so we will discuss later. So suppose that we have the operating system running currently. On top of that, we'd like to create the process. But this one is a passive process, it's a program. It's nothing but, as we have seen here, it's a sequence of instructions. Instead, we are going to copy a.out file somewhere in your memory. Okay? So then this one is called the process. Sometimes it's called the job. Sometimes it's called the task. Okay? For example, multitasking. So many processes are running concurrently. So they are the same meaning. Okay? So sometimes I'm going to call the job. Okay? So more the focus on the meaning of such a process, but it's the same meaning. Sometimes the task, mostly the process. So this is called the process. At the time, this is just the copy of instruction a.out. No. So there will be data structure. We need more information about this. Okay? Later we will see the CPU scheduler. You don't have to worry about what is a CPU scheduler. But for the CPU scheduler, we need the additional information. Where do we keep? And also, sometimes when you run for example, we define integer I, the array. So 100. So first time, if we define the 100, the element of the array, integer I, so we need to reserve the order, the 4 byte of each element, which means the 400 byte. Sometimes we usually start from the I0 and then 1. Even though we define the 100, we don't use all of this. So we need to create all the memory. So we need to think about such a dynamically change the storage used in the program. First time in the a.out file, sequence of file, we don't need such a storage. But when we start to learn the instruction from the beginning, sometimes we need. Also, many of the time, some of the data are inside the block, local variable. Some of them are the global variable. They are the different, okay? As you know probably from the program, global variable and the local variable. Local variable will be the meaningful inside the block of the program, like the subroutine. So that should be represented in this one, in the process. So we need more detailed data structure. So today we are going to how can we structure the process, not only just the sequence of the instruction, but also many other information. While that information are needed while we are processing the process. Okay. So first thing, by the way, who defined such a process data structure? Who defined? We are going to discuss more details of the process data structure. Before we start, who defined? Operating system? It's a compiler. Okay, that's the reason if we are using different CPU or the different operating system, we need to compile. Compiler, no. Actually, the basic data structure good concept is defined by the processor. Then, compiler should know which the instructions are used here when they convert high-level and source code to the object file or the executable file. Compiler should know. Then, even default, for example, 32K. Okay. Then the first 2K is used for the A area, the next 4K is the temporary area, so on. Who decide? The compiler should decide. Okay? So when you develop the compiler program, it's not the using compile, you are able to develop the compiler. Compiler is also software, okay? The program. So which means you can develop your own compiler. Like I'd like to have the Python X, the new program language, which means you need to develop the compiler. At that time, you need to define what is the default size of the process and which part of area do we need and what is the size of this one, and finally it has something garbage collection also. Okay, so this is the part. So that is the reason compiler is kind of the all combination of the basic computer science, the subject. It's really the tough but useful subject. I try to offer that course, but I'm much behind because I'm not from the engineering part. It's purely computer science, but one of the best. So compiler decided the such a thing. Today, we are not going to very operating system or the compiler specific, the process data structure. Instead, it's more generic, the data structure. Okay, most of the process follow this data structure. First, this is also enhanced. Like this. So still the memory address. So from lower to higher address is enhanced part. So when there are three nowadays. The type A.out from the shell, okay, or double click, okay, or the touch. Then you can execute. Execute means the start to load A.out into the memory, which means the semantically creating processes. There are several different interface the operation to create the new process. If that is done, then first we are going to find the memory space. Probably operating system will use the system library, find the memory location, like the malloc, like this one. So then if that can be reserved, then we are going to use the data structure created by such a compiler. First part is the text area. Text area is, as you know, the instruction code. The set of instruction will be copied into the memory because eventually CPU will access such each instruction. Okay. Then will be using the move, that instruction will be loaded into the CPU, and some of the data will be loaded into the copy to the register, and so on will be processed. So text area, the first part is a text area. That text area include this one. Sometimes when you compile, there are two different options. One is the shared library, and another one is a static library. What does it mean? Anyone? Java is not. Java, you can import. Okay? It's mostly shared library, which means somewhere in your memory that the imported library will be located. Then you can use it. But in C or C++ program and some other program, you can, when you compile, there are two options: the shared library or the static library. For example, printf. printf in the C or C++ language or the out. So this is the function somebody already created. Okay? So you don't have to code. If you want, you can code using the system library or the system code. You can code the printf style the function. But you don't have to. Somebody already create like the existing library in Java. So at the time, this module, this library, this one is a very common. So somebody already used in this one. Okay, it's a standard IO, stdio library. Okay, this library is somewhere in your memory. So I'd like to use this one, shared library. At the time, this printf is not part of A.R. Okay. However, I'd like to keep my own printf. So this library will be part of A.R. when you compile. Okay, we are not going to use this one. Instead, I'd like to keep the standard IO, stdio, the code inside my A.R. This is called the static library. Okay, static library will be usually larger than the shared library. So when you compile the exactly same code, but with the static library, it will be huge, really. At that time, even the static library will be part of text. The static library will be here. But if you compile shared library or import, it will not be part of your process. Instead, you will use the shared library as a reference during the execution. So text area include the programming code, okay, instruction code plus if you have the static library code. So that is the first part. Then the second part, text data. If you remember the code, so we define the integer, okay? But there are two types of the variable. What is a variable, by the way? Variable. It's a data structure. So anyway, any program deals with the data information. Is there any program without the data? No. Like even Hello World. So you are using Hello World when you study the first time the program language. Even Hello World in Java or like the Python, the print Hello World means the Hello World itself is the data. Okay. So we need to keep such a data somewhere. That is the variable. Okay. So which means somewhere in your memory it will be reserved. So depending on not depending. So there are different types of the variable as we learned in the program language. Basically private or the public. So public can be accessed by from anywhere, but the private is restricted. And also another type of the variable is local and global variable. Okay? So first time when you learn for example, Java, so if you are not sure what is a private and the public, you just create global variable, which is not recommended. Why? So we cannot guarantee because it can be accessed by any other. Also, from the operating system point of view, our main goal of the operating system is the resource, okay? Better performance. So global variable will be stored the next